sine inverse of 0.2. So where there is x, you substitute with 0.2, isn't it? By expressing sine inverse of x in logarithmic form, determine the value of sine inverse of 0.2. Now the first thing you say, let y be sine inverse of x. So the moment we are able to get y, then it means we found sine inverse of x, isn't it? So here, sine inverse coming on this side of the equation, we have sine y is equals to x, isn't it? Then you come to the exponential function, exponential y is cos y plus sine y, isn't it? Exponential y is cos y plus sine y. So for you to get y, which is the sine inverse of x, then we introduce the Napierian logarithm on both sides of the equation. So if you introduce the Napierian logarithm ln on both sides of the equation, the power y becomes the coefficient, isn't it? So y becomes the coefficient, so we have y ln of e. So ln of e is 1, we remain with y, isn't it? So we remain with y is ln of cos y plus sin y. Now, it is y we are looking for. Y is the sine inverse of x, isn't it? Meaning where there is y, you put sine inverse of x. So it means we found sine inverse of x. Meaning everything on the right hand side of the equation must be in terms of x, isn't it? So for us to get rid of cos y and sin y, we use the Pythagorean hyperbolic identity, isn't it? And Pythagorean hyperbolic identity, we have cos squared y minus sin squared y is equals to 1, isn't it? So from top there we have sin y is x. So if we have sin y, it means it is cos y we are looking for, isn't it? So if it is cos y we are looking for, we make cos y the subject of the formula, isn't it? So we'll have cos squared y is 1 plus sin squared y, isn't it? So for you, what is sin squared y? If sin y is x, meaning sin squared y is x squared, isn't it? So where there is sin squared y, you put x squared. Having done that, find the square root on both sides of the equation to get cos y, isn't it? Find the square root on both sides of the equation to get cos y. So we have cos y is the square root of 1 plus x squared. Now we found cos y and we have sin y. So it means we can substitute the value of cos y and sin y to make the sine inverse of x everything in terms of x, isn't it? So from there we now have that sine inverse of x is ln of cos y plus sin y. So cos y is equal to 1 plus x squared, sin y is x. You can start with the n, isn't it? So we can start with the one without the root, meaning it is sin y plus cos y. So we have x plus square root of 1 plus x squared. So up to that point, you found the logarithmic form of the sine inverse of x, isn't it? So the logarithmic form of sine inverse of x, sine hyperbolic inverse of x, is ln of x plus square root of 1 plus x squared. Then you've been told to use this expression to determine the value of sine inverse of 0.2. So where there is x, you substitute with 0.2, isn't it? Isn't it? So we'll have ln of 0.2 plus square root of 0.2 plus of 0 square root of 1 plus 0.2 square. Where there is x, you substitute with 0.2. So here we have ln of x plus square root of 1 plus x squared. Meaning it is going to be ln of 0.2 plus square root of 1 plus 0.2 squared. The value of x is what you substitute, isn't it? Are we together? So what is the sine inverse of 0.2? ln of 0.2 plus square root of 1 plus 0.2 squared. What do you have? 0.1987. So you have 0.1987. So that is the value of sine inverse of 0.2. So you can confirm by pressing the sine inverse of 0.2 direct to see if you found the right answer. You have to confirm. If you've not found the right answer, it means you've done a mistake somewhere, isn't it? So can you confirm if that is the secant inverse of 0.2 is giving you the same value from the logarithmic form? You have it, it's the same answer, isn't it? So you are confident enough that your calculation is very right. You move to the next question, isn't it? Are you together? Let us move to the next.